All right, good morning, everybody. We are Group 1. The project topic that we've chosen is spam email detection. Okay, moving on. This is our contribution list. All the tasks done by each member is written here. All right, so some background information on this group project is that we will be using artificial intelligence in order to achieve spam email detection. So through the analysis of email content structure and metadata using natural language processing techniques in order to train our machine learning models to identify spam emails and then compare the results of different machine learning models. Okay, moving on. All right, literature review. So some background information on the article is that it focuses on this term called dataset shift. Dataset shift is the distribution of data that changes over time. This change over time is usually caused by adversarial machine learning techniques, spammer tricks, hidden text sorting. This results in models becoming outdated as they were trained on outdated data that is no longer representative of current real world situations. This results in models needing regular updating. So how this article decided to tackle this theory is they use two things: spam filters and AI with NLP techniques such as bag of words and term frequency in order to analyze the email structure and then clean the email structure and then return it back to the spam filter, which is then used in their testing. So what result came out was that it showed that the performance of the spam filters actually deteriorates over time due to the dataset shift as well as changes in the spammer strategies. So one thing that they have also identified is that using older data to test new data will result in the data in the model testing for lower accuracy. So if you were to use newer data to train the model and then test the new data, it will result in high accuracy. So in this case, the relevance of the spam source to calibrate the model is very crucial in this situation. All right, now let's move on to the next slide.
Now let's take a look at the data frame structure looks like. Each row represents a single email with key fields such as message ID, date, from, to, subject, and body text. The Enron email dataset consists of 500k emails from 150 senior Enron employees created by Carnegie Mellon University. Instead of using a pre-processed dataset, we manually create our data frame from the raw email files. Going to the next slide. Once we extracted the raw email data, the next step was pre-processing the text to make it suitable for machine learning. First, we address obfuscation where spammers disguise words to bypass filters. For example, replacing L with 1 in click to avoid detection. To counter this, we build an obfuscation replacement dictionary that automatically converts these altered words back to their original form before processing. Next, we use regular expressions rejects to detect advanced spam techniques such as mixed letters and numbers and white font hidden text within HTML emails. This allows us to measure the level of manipulation in each email by calculating observation percentage. We also handle missing data by applying drop-na, which remove incomplete records that could affect model accuracy. Finally, we applied a text cleaning process that removed unnecessary characters and stripped out HTML text and eliminated spam keywords dynamically loaded from the spam keyword text. This ensures that our spam detection model can accurately classify emails even when spammers try to evade detection.
Now I will talk more about the spam email classification. The classify spam function determines whether an email is spam or ham based on the maximum obfuscation percentage. It checks whether any spam keywords appear in the email header or text. It consists of three special conditions. Condition 1, if an email shows extremely high obfuscation of over 150% but originates from Enron domain, it is marked as ham. Condition 2, if spam keywords are there or the obfuscation percentage is over 30% for non-Enron emails, the email is classified as spam. Condition 3, additional checks for financial scam-related terms further flag the email as spam. This function is applied to every email in the data frame and a new column is created with the classification result. Moving on to feature extraction and data transformation. The term frequency to inverse document frequency statistic is used to show how important a word is to a document. Max features equals to 7,000. This helps reduce noise from extremely rare words and keeps the feature space manageable. Stop words equals English removes common English stop words like the, is, at that usually do not have significant meaning. N-gram range equals 1 to 3. This captures context and phrases which can be useful in detecting spam patterns. Sublinear set to true so that the influence of very frequent words is reduced. Norm set to level 2, which is a standardization for comparing documents. Use IDF and smooth IDF, which is enabled for inverse document frequency. Down to downweight common terms and avoid extreme IDF values for rare weights. Finally, we visualize using a pie chart where the script calculates the number of ham versus spam emails, where we can see the balance between the two classes in the dataset.
Of training multinomial naive Bayes, which is ideal for text classification via counting word frequencies. So how it works, it uses Bayes' theorem with minimal parameters. The pros, it's simple and fast to implement, it handles large feature sets effectively, it performs well even with limited training data. The cons, it assumes each feature is independent, which isn't always true in the real world scenario. It can be affected by irrelevant attributes, may even assign zero probability to unseen events. Next, the rich classifier. It is tailored for multi-class classification by combining classification with rich regression. So how it works? It applies L2 regularization to reduce overfitting and manage correlated features. The pros is more reliable with noisy or volatile data, and it also balances the influence of correlated features effectively. The cons, finding the right balance, bias versus variance can be a little challenging. It can be slower to train on large data sets. It also assumes all features contribute, which is less ideal for sparse or irrelevant data.
Next up, we have the SGD classifier. The SGD classifier is well suited for handling very large datasets efficiently, making an excellent choice for scalable applications. Its ease of implementation allows for seamless integration into existing systems, making it particularly useful in spam detection, where vast amount of emails or messages must be processed in real time. Additionally, its ability to handle high-dimensional feature specs, such as TF-IDF or word embeddings, enhances its effectiveness in distinguishing between spam and legitimate messages. However, selecting an appropriate learning rate is crucial for ensuring proper convergence, as an incorrect choice can hinder model performance. However, the stochastic updates introduce noise, which can lead to fluctuation in the loss value, making training less stable. So this is the confusion matrix of our SGD classifier. So moving on the other hand, the random forest algorithm is more robust to noise and less prone to overfitting, making a reliable choice for spam detection, particularly in cases where spam messages contain a mix of structured and unstructured features. Its ensemble-based nature ensures strong predictive power by aggregating multiple decision trees, reducing the likelihood of misclassification. Additionally, it performs well with large datasets and high-dimensional data, making it effective in detecting spam patterns across diverse sources. However, training a large number of deep trees can be computationally expensive and memory-intensive, posing challenges in resource-constrained environments. Furthermore, determining the optimal amount of features considered at each split requires careful tuning to achieve the best performance. By leveraging feature selection and dimensionality reduction techniques, the computational burden can be minimized while maintaining high classification accuracy.
Thank you. So for linear SDC, it is efficient in handling high-dimensional data, which is common in emails. It is simple and speedy due to its nature of being less intensive during training and inference, and is very robust as it is used in many text tasks. So some cons of linear SDC is that it is limited to its own linear boundaries, is sensitive to parameter tuning, and it's not as good in handling imbalanced data. So from our testing results, we have overall 94%, which is pretty good accuracy. So moving on to stacking classifier, it improves performance through diversity, using the models previously mentioned, and it is very flexible. So some cons is that it increases complexity with the number of models being used, and increases computational costs. This might result in overfitting as well. So the results of this classifier in our testing is a very nice overall 95% accuracy.
As we can see in the bar chart, our stacking model is the better one because we combine all other four together with heat-pretty boosting classifiers, which allow our model make more stable predictions. In overall, our results are very positive as all other models are score higher than 80%. And to make our stacking model become better, we can apply grid search to identify best parameter and make other combinations such as PERT and CNNs, and using other work embeddings such as dimensional reduction. And also apply SMOTE in data handling that commonly used in imbalanced datasets. In conclusion, for developing spam email detection model, we have to done the data cleaning and pre-processing, selecting model for development and training while understanding why some model perform better. In addition, we embed our stacking model into our website. Here is how our website looks like. An input field to input emails, a text area to input the email bodies. And now let's see how it works. Click run and the output prompts, and then click on the resets to reset everything. That's all what we have. Thank you.